In this video we're going to discuss the main features of a topographical map, and I'll show you how to describe your position using grid references. Later, I'll show you where you can download some free world topographical maps to practice with. Topographical maps are used by hikers, bushwalkers, surveyors, emergency services, and others who have an interest in the height and shape of the land. Today we're looking at Australian topographical maps, but maps from other countries are drawn in a similar way and have similar features. Unlike street maps and marine charts, a topographical map is mainly drawn to identify topography, that is, the shape of the land, the shape and height of hills and valleys, the course of rivers and streams, as well as distinctive man-made features. On the side of the map you'll find information about the name of the map, scale of it, a key of symbols showing you what various symbols mean on the map. You'll also see a pointer showing the locations of true north, grid north and magnetic north. I've talked about this in a previous video which I'll link in down below, but understand this feature of the map is important if you're measuring direction with a compass and then drawing that direction on your map. Maps are drawn to scale. In this case, the scale is 1 in 25,000. That means 1 centimetre on the map is the same as 25,000 centimetres, or 250 metres, on the ground. You can measure distances on the map by using the scale, usually located at the bottom of the map. Each map has black squares drawn on them, which are often 1 kilometre by 1 kilometre in size, although you should always check the scale to confirm. The squares are aligned with position information along the top, bottom and sides of the map. We'll talk about those soon. Probably the most obvious thing you'll notice on a topographical map are all these contour lines shown in brown and grey. These describe the shape of the Earth. A contour line joins places of equal height above mean sea level. So if you walked along a contour line, it would be fairly level. Here, contour lines are spaced every 5 metres in grey, with a dark contour line in brown every 50 metres. That's for easy identification. Different maps have different contour intervals, so be sure to check the information on the outside of your map for contour intervals. You can tell the shape and slope of the land by viewing these contour lines. On the top here we have a series of contours for hills, and below is the cross-section view of that hill. You can see that lines which are close together, like these on the left, have a steep slope. Contour lines which are spread apart have a shallow slope. Contour lines which are spread evenly have an even slope, and contour lines which are unevenly spread, like these ones here, have an uneven slope. I mentioned the position information relating to these black squares. Along the edges of the map are marks and numbers used to identify your position on the map. The marks along the top and bottom are called eastings, and they increase towards the east. The marks along the side are called northings, as they increase to the north. Starting at the simplest form of position information, we can identify where we are in this grid square by using a 4-figured grid reference. To do this, we identify the bottom left corner of the square we're interested in. First, we read off the eastings. In this case, it's 6, 5. Then we read off the northings. Here it is 7, 0. So the 4-figure grid reference for this square is 6, 5, 7, 0. Now you should note there are many topographical maps around the world which have a grid reference of 6, 5, 7, 0. So it is important to refer to the map title when giving a grid reference like that. If we want to get more specific, we can divide the grid square into smaller parts. Here it is divided up into 10 squares by 10 square grid, 100 metres across each grid. We can identify our position more accurately by using a 6-figure grid reference. As we did before, we read off the eastings and then the northings, but in this case we read off 3 figures in each direction rather than 2. So the easting is 658 and the northing is 703. The 6-figure grid reference is 658703. You can divide those little squares into 100 more little squares, each 10 metres across. This would allow you to create an 8-figure grid reference, but we're not going to go into that much detail today. Now these grid references are a subset of a much larger grid system known as the Universal Transverse Mercator, or UTM. The higher levels of this system are shown here. You can see, like the lower level maps, the world has a grid system overlaid onto it. It has eastings and it has northings. And so you can see the eastern section of Australia can be identified by the easting 56 and northing J to form 56J. Those squares are quite big and so aren't very useful. So the powers in charge divided them into 100,000 square metre squares like these. Each square has a 2-letter code. The 100,000 metre square for the area we're looking at in Australia is MR. So the full grid map reference for this position is 56J MR 658703. This is known as the full grid reference and is unique throughout the world. Now I said I would tell you where you could download some free online practice charts. Well, I'm pleased to say that the New Zealand government publishes all of its topographical maps online, free for you to download. I'll publish the link down below. You can download not only topographical maps for New Zealand, but also some maps of New Zealand's Antarctic claim. If you hunt around the site, you'll find they also publish all of their marine charts as well. So thanks to Land Information New Zealand for making real-world maps available for everyone. So that's it for this quick lesson on topographical maps. There was a lot in there for such a short video, and I encourage you to pull out a topographical map or download one and have a look at the features we've discussed today. Thanks for watching, and don't forget to leave your comments below or subscribe. Bye-bye.